All right, so we left off when we were talking about normally distributed data. So normally distributed data, that means you're using what's called the bell curve. So all of these have bell curve. So it says a normally distributed data set has a mean of 40 and a standard deviation of 8. Find the probability that a data value chosen is greater than 35. Okay, so remember the key to these problems is drawing a picture. So we're going to draw a picture. We know our mean is in the middle, and it's 40. Our standard deviation, that's our sigma. So sigma is equal to 8. We're going to find the probability that a data value is greater than 35, and 35 is on the left of 40. So we're going to draw it on the left. Now, a lot of people in my first period class were confused because they thought that on the left side it was always negative. Okay, that's only on the standard normal table with a mean of 0. Okay, so we are going to change our value so that we can use the standard normal table. So when we change this to a z-score, do you guys remember z? Z is x minus mu over the standard deviation. So we have 35 minus 40 over our standard deviation was 8. So let's see, we get negative 5/8. So find what that is as a decimal for me. So negative 0.625. Okay, and we run into a little bit of a problem because if you look back at our chart, we know we're going to look up positive 0.625. But we have a bit of a problem because as we go down to 0.6, so this row, and then over to 0.2, it has to be between 0.02 and 0.03, right? It's 0.625. Eric, you with me?
Do you round up?
Yeah, so you got to round. So, yep, a lot of people, if you have 2 of them, a lot of people will just say, okay, I'm going to find 0.62, I'm going to find 0.63, I'm going to find the probabilities for both, and then you're going to take the average of the 2. You can do that. We're just going to round. So we're going to round. So if I had 0.625, it rounds up to 0.63. So I'm going to have negative 0.63. That's my z-score. So when I look on my chart, I'm going to look at the 0.63. So that's this value. So 0.7357. So I put that in, so 0.7357. Now, question. I told you yesterday that the easiest way to think of these is what's your big area, what's your small area, right? We know that half of our bell curve is 0.5 because the area underneath the bell curve is 1 always. So if I'm talking about 0.7357, is that this piece or this piece, so left or right?
Right.
It's the right side, right? It's more than 0.5. So it's the big piece. Okay, so that's what goes in here. We want the probability that the data value is greater than 35, so we do want that area. So that's our probability. Remember, if you want to impress me, you can use your x's and z's. You can say the probability that x is greater than 35 is the probability that z is bigger than negative 0.625. Or you could do 0.63 since we used, I guess, which is 0.7357. And that's your answer. Okay, if you do not write the x's and z's, I will be fine with that on your test. Just know that if you only have numbers, and I don't know where these numbers are coming from, like they're not the right numbers from the table, I don't know how to give you partial credit. Does that make sense? So write as much as possible to get your partial credit. All right, so let's try the next one. So it says a radar unit is used to measure the speeds of cars on a motorway. The speeds are normally distributed with a mean of 90 kilometers per hour. And a standard deviation of 10 kilometers per hour. What is the probability that a car picked at random is traveling at more than 100 kilometers per hour? So that's our x value, 100. And we want more than that. So we want on the right side. Okay, so if you look at your chart, you can't plug in 100 onto your chart. Right, your chart only goes up to like 2.9 or something. Okay, so we need to change these to what we call z-scores. So I'm going to change it to z, so it's going to be x minus mu over the standard deviation. So it's 10 over 10, which is 1. So my z-score is 1. So I go back to my chart, and I look up 1 on my chart. Oops. So when I look up 1, go down to 1.0, and it's 1.00, right? So it's 0.8413. Okay, that's a pretty big area. So 0.8413 is the area leading all the way up to that z-score. It's the bigger area. The smaller area is what we actually need. So what do I do again? Yeah, the whole thing makes 1, so this has to be the rest of it. So you're going to do 1 minus 0.8413. Remember I gave you a trick? I said you want all the numbers that add to be 9 for each spot. So 8 and 1 make 9, 5 and 4 make 9, 8 and 1 make 9, and then the very last spot you want to make 10. So 7. So 0.1587. That ends up being your answer. So 0.1587. All right, you guys go ahead and try the next one. It's about Brian Pulaski here. Okay, so it says entry to a certain university is determined by a national test, probably the SATs or something like that. The scores on this test are normally distributed with a mean of 500 and the standard deviation of 100. Brian wants to be admitted to this university, and he knows that he must score better than at least 70% of the students who took the test. So I guess that's what the admissions department told him when he called. All right, Brian takes the test and scores 595. Will he be admitted? We'll see. So go ahead and try it. Yeah. Yeah, the question is, how did I know that all of you guys were going to be in this class and I used your names in my notes? I asked Miss Davis every year who's going to be Algebra 2 students, and I changed it every single year. Yeah, so if you haven't shown up yet, maybe you'll show up next time. Some of you came during summer, so I didn't know. All right, here we go. So our mean is 500 and the standard deviation is 100. So when I draw my bell curve, I put 500 in the middle. His score was 595, so that's the x. Mu was 500. Standard deviation, we said, was 100. That's our sigma. All right, we want to know the percent of people who scored lower than him. That would be his percentile, right? If like 80% of the population scored less than him, he got in the 80th percentile. Okay, so we have, we want to change this to a z-score. So I'm going to have x minus mu over the standard deviation. So it's 95 over 100, which is 0.95. So I'm going to look up 0.95 on my table. So I go back to the table. I go down to 0.9. So I'm in this row. Go over to 0.05, right? 0.905, right? Add them together. You get this number. So 0.8289. Did you guys get that number? 0.8289. All right, that is the bigger area. Oops. So that's this area here. So 0.828, is that what I said? 8289? Yeah. All right, that's the area all the way up to that z-score. Okay, so that means that Brian has scored in the 80, we'll say 83rd percentile. I think it's actually 82nd. I gotta look that up. Okay, so 80. So will he be admitted?
Yeah, we should probably study more.
Yes. Yes, but he should study more because he needs to be in the 90th percentile to assure it. Is that what you think? Yeah. I don't know. All right, next up. I don't know what this story problem is about, but it doesn't make any sense whatsoever. So for a certain type of computers, the length of time between charges of the battery is normally distributed with a mean of 50 hours and a standard deviation of 15 hours. Okay, most computers don't last 50 hours. I don't know what I was thinking. So maybe I should say some kind of calculator or something. All right, so Mr. Sarek owns one of these computers and wants to know the probability that the length of time will be between 50 and 70 hours. Okay, so our mean is 50. Oops. And our standard deviation, guys, is 15. Okay, we want between 50 and 70 hours. Hey, Erica, you're going to have to move. Here's 70. All right, we want between 50 and 70. So we want right after the mean all the way up to 70. That little area right there. Yep, so we need to find the z-score just like normal. So my z-score is x minus mu over the standard deviation, which is 15. So you get 20 over 15. They're both divisible by 5, so 4/3. So 1.33 is what it's going to make. Okay, that's the z-score. So I'm going to look up that z-score. Have to keep going all the way back. Okay, so 1.33 is right here. So 0.9082, did you guys see that?
0.9082?
Yep. Okay, what that represents is the area under the curve from the far left all the way up to that z-score. So 0.9082, that's a big area, right? Okay, so we have 0.9082. We don't want that whole area though. We need to get rid of the white space over here. Yeah, good job. Subtract 0.5, right? Because that's half the bell curve. This is 0.5. So if I want this probability, so if I want the probability that we're between 50 and 70 hours, that's the same as the probability that your z-score is between 0 and 1.33. But we basically end up doing my 0.9082, and we subtract out 0.5. So we get 0.4082.
Wait.
What about the other 0.5?
It doesn't look right. Like, no, I guess it's just your drawing.
Yeah, I mean, my drawing's never perfect, yeah. It's probably further over here, is that what you're thinking?
Yeah.
All right, you guys try A, B, and C for number 8. So try A, B, and C. See how you do. I'll even let you guys write it up here if you want. Ooh. You gotta get it right first, though. You gotta try it first.
Take my book.
All right, so your mean is 50,000. Your standard deviation is 20,000. So what percent of people make less than 40,000? So 50,000 is in the middle, 40,000 is going to be below it.
Cool.
You want less than that. So you want all the way up to 40,000. You need to find the z-score. So z equals 40,000 minus 50,000 all over 20,000. So you get negative 1/2, so negative 0.5. So when you look up 0.5 on your table, what do you get? 0.6915. So that is a big area. It's more than 50%. So 0.6915 is this bigger area. That means that on the left, I have the remaining amount. So I have 1 minus 0.6915. So I get 0.3085. So 0.3085 should be your answer for part A. How many of you guys got it? Good. Several of you. All right, what percent of people earn between 45 and 65,000? Okay, so this time you're on the left and on the right, so 45 to 65. So you need to find z-scores for both things. All right, so your z-score for the first one is going to be 45,000 minus 65, or minus the mean, 50,000, right? Divided by 20,000. What do you guys get for that first z-score? 0.77? Negative? Is that right? I don't remember that number. Check that. Okay, what is 45,000 minus 50,000 all divided by 20,000? Negative 0.25, that's what I'm asking. Okay, now this other one, z-score. Your z-score is 65,000 minus 50,000 divided by 20,000. So what's this z-score? 0.75, okay. So you're between negative 0.25 and 0.75. LJ, with me? All right, so you need to look at these values on your charts. So if you look up 0.25, what do you guys get? 6915. So that is going to be,
Wait, no.
no, that's,
It's
oh, yeah, you're giving me the wrong numbers. It's what?
5987.
5987. Okay, that's the big piece from the z-score over this way, 0.5987. Hey, I know it's Friday. Hang with me. You're not going to be able to do your homework. 0.5987. All right, we need on the left here. Okay, this is how I always do these problems. So I have the part in the middle, so I always find what I call the tails. I find the white part on the sides, right? Okay, so if I had 0.5987 for everything past that tail, that means I'm going to do 1 minus 0.5987 to get the tail. Okay, so this piece ends up being 1 minus 0.5987, which is 0.4012, or 3. All right, now this other tail I need to find. So if I look up the other z-score, which is 0.75, what do you guys get when you look up that z-score? 0.7734, you guys agree? All right, that means that this tail is 1 minus 0.7734. So it's 0.2266. Okay, so your final answer is 1 minus each of the tails. So 1 minus 0.4013, and then you take that answer and subtract out 0.2266. Brian, did you get that? Did you get it?
0.3721.
0.3721.
Wow.
All right, is this making
Hey,
sense?
Alex, why don't you like not do that? Okay. Come out here.
All right, C. What percent of people earn more than 70,000? So more than 70,000. So Brian, you said you did do this one? Is that what you said?
Yes.
All right, so what'd you get for your z-score? So you put 70,000 in.
Right.
So what'd you get for z-score?
You get 1.
1 exactly. Yep, because 70,000 minus 50,000
20,000.
divided by 20,000. Yep. Okay, so you looked up 1 on your table. What'd you get for when you looked up 1?
0.8413.
0.8413. That's representing this area. We want more than 70,000, so we went over here.
You have to do 1 minus that.
Yep.
You get 0.1587.
Yep. 0.1587. Are these making sense?
Yeah.
All right, let's try the very last one. Okay, so the time it taken to assemble a car in a certain plant is random variable. They always say a random variable meaning like, I don't know, you have a random sample. I don't know how to explain that, but anyway, it says normal distribution, so that means bell curve, of 20 hours and a standard deviation of 2 hours. So in the middle, we have a mean of 20 hours. Standard deviation is 2. What is the probability that a car can be assembled at this plant in a period of time less than 19.5 hours? So 19.5 is pretty close to 20, but we want everything less than 19.5. So I need to change it to a z-score. So x minus mu over the standard deviation. So x minus mu over standard deviation. So it's negative 0.5 divided by 2. So negative 0.25. Okay, we can't look up negatives on our table, so we look up 0.25. We've done that one before. What is it? 0.5987. Okay, this one's kind of tricky because they're really close. Which side, the right or left, is 0.5987? The right, because it goes a little bit more than halfway, right? Here's halfway. It goes past it. So this is 0.5987. Okay, we want the other side, though. So we want 1 minus 0.5987. So we get 0.4013. Okay, the next one says between 20 and 22 hours. Our mean was 20, so it's starting right at the center, and it's going to 22. Okay, this is one of those ones, like Alex was saying, you can just subtract out 50%, like 0.5. Okay, so I found my z-score. You could also find the z-score for the mean. What's the z-score going to be for the mean?
0.
0, right? That's why we use the standard normal table. The standard normal has mean of 0, standard deviation of 1. All right, so z is going to be 22 minus 20 over standard deviation of 2. So 2 over 2 is 1. If you look up 1 on your table, what do you get? 0.8413. Okay, that's everything up to my standard, or to my z-score of 1. Okay, but we don't want all of that. We want to subtract out this piece right here, which we know is 0.5. So I'm going to have 0.8413 minus 0.5, so you get 0.3413, and that's your answer. All right, I do want to mention that on your homework, you guys will have a weird one. So kind of look back at that one that talked about Brian. Okay, so I should have done like a part B for this, but I might also ask something like, what score gives a 70th percentile? And you have one like this on your homework, so let's kind of think about it really quick. So if I'm asking for what score gives a 70th percentile, you're going backwards. Here's what you're thinking. You're thinking, okay, my mean is 500. I want some score. I don't know what this is. And I want the area under here to be 0.700, right? That's 70%. 0.7000, I guess. Okay, how do you think I would go about finding that?
Find it on the table.
Okay, what do you mean by find it on the table? Find what?
Find something that gives you in the result.
Yep, you want to find the z-score that gives you a result of 0.700. So you're looking through this middle part of your table, and you're saying, okay, I want 0.7000. How many zeros? I keep losing track. All right. Yeah, it looks like it's in this row somewhere, the 0.5 row. It looks like it's either this one or this one. We need to know which one's closer, probably. Now, you could just use the average of the two. So we know that it's between 0.52 and 0.53. So you could use 0.525. Does that make sense? You could. We'll just use whichever one's closer. So this one is 0.0015 away. This one's 0.0019 too far. So which one's closer?
0.52.
Yeah, the 0.52, the one that gave 0.6985, right? So we're going to use 0.52 as my z-score. Okay, so that means that's my z equals 0.52. How do I find x then?
You have to find the x that which you subtract the mean and then divide.
Yeah, so use that formula, right? So you have z equals x minus mu over the standard deviation. So your z-score is 0.52. X is what we don't know. We do know the mean, and we do know the standard deviation. So we solve it, just like normal. Multiply the 100 over. You get 52 equals x minus 500. Add the 500, 552. So Brian did much better than that. Right? Well, not much better, I guess. 595, right? Better than 552. So if he had a 552, he would have been right on the edge of that 70th percentile. Okay? Does that make sense? So you do have one like that on your homework.